In this video, we will solve this example conversion from standard condition problem. So we have hexane at 450 degrees Celsius and 6 atm absolute pressure, which flows into a reactor at a rate of 800 kilograms per hour. We want to know the volumetric flow rate of this stream using conversions from standard condition. So first we need to get the formula, which is P times volumetric flow rate divided by standard condition pressure times V hat for standard conditions, and this is going to equal the molar flow rate times temperature divided by standard temperature. So this is right here is going to be our formula, and we want to calculate the volumetric flow rate. In doing so, we need to rearrange this equation right here. We want to solve for V dot. We want to solve for the volumetric flow rate. And so now the equation, when we rearrange it, we would get V dot is equal to, so N would be the same, times T, which is going to be the same, but times this part right here. So we just need to write it down. And now we need to divide by, so we're going to divide by TS, and we will also divide by P. All I'm doing is rearranging this equation right here into a form where it would be easy to calculate the volumetric flow rate. So P times TS. And now we need to calculate each component. So we need to calculate the molar mass. So N dot is equal to, we have 800 kilograms per hour, and we will divide this by the molecular weight for hexane, which we could say is 86.2 grams per mole, or you could say kilograms per kilomole. And this right here would give us 9.281 kilomoles per hour. So now we got N. But next we need to calculate T. The T value, we would want it in Kelvin. So we have 450 Celsius, and to convert Celsius to Kelvin, we simply add 273.15, and this would give us 723.15 Kelvin. So now we have N and we have T. Next, we will calculate pressure, which is already in a nice form. So pressure is 6 atmosphere. So now we have everything. PS and TS are standard values, and so when I actually enter these numbers in, I'll tell you what PS and TS will be. So N was 9.281 kilomoles per hour. That's N. Next we have T times temperature, which we said was 723.15 Kelvin. PS, the standard condition, is 1 atmosphere. That's always the case. Times VS, which is also be 22.4 meters cubed per kilomoles for STP. Divided by P times TS. P was 6 atmospheres, and TS is always 273.15 Kelvin. And now let's see what our units will be. So this kilomole cancels with this kilomole. This Kelvin cancels with this Kelvin. This atmosphere cancels with this atmosphere. And now we have meter cubed per hour. And so this right here would be 91.73 meters cubed per hour, which is our volumetric flow rate, which is correct. And that's all we need to do for this problem.